Hello, Adolfo from Portainer here, and in this video we're going to do a behind the scenes of the demo that we did with Canonical last week during Kubecon on May 7th, where we showed this nice interesting topology of two Kubernetes clusters. One is a MySQL cluster, the other one's a Charmed Kubernetes cluster, running two MySQL databases, one each. They're actually separate clusters. And we did a sync of these two databases that are running within these clusters. And the MySQL cluster is picking data from two IoT sensors, two IoT devices, and everything is connected via VPN Mesh. And finally, everything is managed by Portainer. And the steps that I will show of how this was done is starting with the installation of the clusters. Actually, you can refer to the video here on the MySQL deployment and here on the Charmed Kubernetes deployment. So those are sort of prereqs in order to replicate this demonstration, but they're there for you to have a reference of how these were deployed, how I did the deployment of the VPN Mesh, so everything talks to everything, adding the endpoints to a Portainer master instance. So I will have, as you see here on the top, Portainer master instance managing these two clusters. The configuration of the IoT devices, how I did this, how I installed the MySQL databases, the replication between the databases, the Grafana console, and finally how I set up Grafana to be able to display the information the databases were receiving from the IoT devices. So, okay, we will show here how this was done. So on the next video, I'm going to start with I'm going to skip the first part because, as I mentioned, you can see it on the videos I referred before. And I'm going to go straight into installing the VPN Mesh on the Kubernetes clusters and IoT devices. So, okay, here we go. Okay, so here I have a console with 4 machines. I'm connected to 4 machines here on this terminal application. And I want to show you that each has IP address that is part of the mesh. So let me just copy it and paste this to the other machines. Okay. So the subnet was set was the 10.147.20 from 11 to 15. Yes, 15. So as you can see here, I have 11, 12, 13, 14, and there's a 5th machine, which is the Portainer instance, the main instance that I had mentioned previously on the topology, which is this machine here. This machine on the top has the IP 15. Right. So you can have an idea. These are the IP addresses that I'm using for each machine. Edge 1, Edge 2. 11, 12, 13, 14, 15. The edge machines are actually 2 Raspberry Pi Zeros. They're running the DHT22 temperature and humidity sensor, so that's how they're picking that information. And on one of the next videos, let me see which one. On video number or on item number 4, I'm going to show how I configured them and how they're connected to the MySQL databases. Now you're going to ask, what VPN mesh am I using here? And I am using 0 tier. And why did I pick 0 tier? 0 tier is very easy to deploy, to implement. You can have a network with up to, I think, 100 nodes, 100 machines, all connected for free. I don't really know much of the pricing here. Yeah, so it's a free membership, sorry, up to 50 machines. And well, for the purpose of this demonstration, obviously, I only needed 4 or 5, and that was more than enough. It's a very easy VPN technology. It's actually a VPN mesh. It's not a point-to-point VPN technology, but you can use anything. You can use WireGuard, you can use OpenVPN, you can use, if you want to use another type of VPN mesh, there's Nebula that is being developed by Slack, which is also quite interesting. I personally like, for these small deployments, 0 tier because it's very fast and easy to install, and it's very stable. And there's a very interesting interface here. determine the IP addresses that you want and the name of the machines. This machine is my laptop actually, but as you can see, all the other IP addresses I showed you are here. So take a look at this. If you don't like Zero-Tier, again, you can use any other VPN mesh technology. This is the one I picked for the demo. Right then, so let's check on the next video. Let's see, and that's going to be adding the endpoints to the Portainer master instance, which is this instance here, and how I added these clusters to Portainer via the Portainer agents. Okay, hello. Now we're going to add the 2 Kubernetes clusters as endpoints to my main Portainer instance. So as you can recall, we have a separate machine for Portainer. It's good practice especially if you're running Kubernetes clusters in a production environment, to have a separate Portainer instance running on a separate machine. It can be on a virtual machine or a laptop, or that's entirely up to you. But as long as it's just a dedicated machine that will connect to the clusters via Portainer agents, that we call them. So now we're going to see how to deploy these Portainer agents on these clusters. So first I'm going to log into my Portainer instance. So I'm going to log in as my admin user. Right. Okay. This machine is actually running on Docker. It's not the machine where I have Portainer installed. And it's, you just need a simple deployment of Docker so you can have access to a Portainer instance. I could have used micro K8s if I wanted also. That's entirely up to you. If you just want to use everything purely on Kubernetes, a simple micro K8s node, one node with Portainer running would have been enough. I'm not going to use this endpoint, so I'm going to remove it, but I am going to add the 2 other Kubernetes clusters. I'm going to start with the micro K8s. The micro K8s machine is running on my local network, so I'm going to start by deploying Portainer on this cluster. I'm going to copy the command here, and I'm going to do it via a node port. I'm going to copy the command, go back to the terminal window, and here, micro K8s. I'm going to paste the command. Now, just before hitting enter, because it's micro K8s, you might want to just add the micro K8s before the kubectl apply f Portainer agent YAML file, just to be on the safe side. As you know, when you deploy micro K8s, kubectl equivalent to micro K8s is micro K8 space kubectl. You can actually write an alias that I have on my bash aliases file here on my machine, where I alias kubectl to the micro K8s kubectl command, and helps me to get pod, see how my Portainer agent is running. It's up and running already. As you can see, it's the agent only. That's all I need. And now I'm going to connect this cluster via the Portainer agent to my main Portainer instance here. I know the IP address here is, let's see, rep 147.14. Okay, so I'm going to call this micro K8 10.147.20.14. The port is 30778. When deploying it this way, add endpoint. Okay, successfully added. I will not configure ingress or load balancer, none of this. I'll just add storage. I might not even use storage, not at least for the sake of this demo. I didn't use any persistence. So, but if you want to have a persistence on your database, obviously you would have to add this storage option here as your default storage for your Kubernetes. Okay, I'm going to save this configuration, and now I'm going to add the Charmed Kubernetes Portainer agent here. Same thing. Go to endpoints, add endpoint, Kubernetes via node port. I'm going to call it Charmed. Let's go to the terminal. IPA 147. It's 13. So I'm going to copy the command, Now, the Charmed Kubernetes distribution is slightly different. I'll show you how I logged in. I logged in using Juju, SSH Kubernetes, and I only have one mode on this Charmed Kubernetes cluster, which is worker 0. So with this, if you follow the video that I mentioned earlier on how to deploy Charmed Kubernetes, you would learn how to use the Juju tool to be able to deploy a Charmed Kubernetes cluster. Okay, and I'm going to log in as root. So now I'm going to paste the command. I don't need to put micro K8s before kubectl here because this is a pure Kubernetes cluster running. It does have kubectl installed in the machine. Right. Okay. That's right. kubectl get pod on namespace Portainer. And it's up and running. The IP here is 13. Is it 13? Let's check. Yes, it's 13 for Charmed. Okay, here it is. Copy. Again, the port is 30778. With this, I can add this endpoint. It's added successfully. I will add the Ingress controller. I will not add the load balancer. I did not use a load balancer for this demo. I only use the Ingress controller. I'll show you this in the following video. Right, I'm going to activate local storage. I'm going to save the configuration. Again, I didn't use persistence in this demonstration, but if you want persistence, you want to make sure you enable the local storage or whatever storage technology you're using for your Kubernetes clusters. So this is how you add the endpoints. It's very easy. I managed to do this because, as you remember in the topology, everything is connected to everything. The IoT sensors, the micro K8s cluster, the Charmed Kubernetes cluster, the Portainer machine, they're all connected via the same VPN mesh. Okay, see you soon on the next video. Okay, so now we're going to set up the IoT devices so they can send data to the MySQL databases. I haven't yet installed the MySQL databases on the clusters on any of the two, but I want to make sure that the IoT devices are operational. They can read data from the sensors and they can write that to a format that the MySQL database can load. Now, it's not the cleanest code on earth, I must confess. It's good enough to be able to send the information to the MySQL database. I'm sure there are other methods, probably even better than this one. I'm not a programmer, I'm not a coder, but it's good enough, at least for the purpose of this demo, to show data being written to the MySQL database and then that being replicated to a second MySQL database on the Charmed Kubernetes cluster, which is the intent of this demonstration. Okay, so the script is called update. Basically what it does, it's a loop. Every 2 seconds it reads from the sensors through this Python script called humidity. If I run humidity here, you will see that basically what it's going to give me is 2 readings. The first one, 25.7, the temperature, and 98.0 is a percentage, which is a percentage of humidity where I am. So I get these 2 variables and I write them to a SQL dump that I then send to the database on the micro K8s cluster. And then we'll, on the next video, I'll show you how I set up the databases and did the replication. Now, you see that the IP address here is wrong. It's not 144. It's actually 13. Let me check the micro K8's IP address. Let's see. Sorry, 14. So it's got a typo here. Let me update the script. So basically, I'll go very quickly over what the script is doing. So here I generated some variables that have to be written to the code.sql file. I open the file. I write these variables that I read from the humidity script in Python. that picks that up from the sensor. And then I send this file to the corresponding MySQL machine, right, which is the micro K8s node. And then I run a command so that MySQL can update the table with this information. So it's basically that, and it runs every 2 seconds. I keep it in a loop, and that's pretty much it. If you want to leave that on the background, there are tons of ways of doing that. You can use tmux, you can do screen, or you can leave this on running as a service on your little device. Again, it's not the nicest, best code ever, but it's just enough for the demonstration. Now, as you can see, it's doing an SCP and an SSH. The SCP is to send the file to the server that hosts the MySQL database on the micro K8s cluster, and the SSH is to run the command of the MySQL client to write what's in this file to the corresponding database. This requires you to have an SSH key on the other end. So I have to make sure, and the user is AD Lorenzo, which is my user. So you have to make sure that the key is installed on the node where you're going to load the script. So in theory, if I do SSH AD Lorenzo at 10.147.20.14, I should log in automatically as user AD Lorenzo, so it worked. Okay, so with this, I can send files and I can send commands using SCP and SSH to the micro K8s machine. Okay, now on the machine running the MySQL database, which is the micro K8s node, I have to make sure that the MySQL client is installed. So I'm going to install the MySQL client. I'm using Ubuntu, so it's the apt package manager. MySQL client. Okay, so with this, I'm almost done. One last thing that you have to do is use the MySQL config editor. Let me clear the screen here so you can see it, how it's done. Because you don't want to send the password over the terminal via SSH, you can use the MySQL config editor to write the settings that the edge or IoT device is going to send over SSH to the node. So it's MySQL config editor set host equals 10.147.20.14. Port I'm going to use for this MySQL database is going to be 3036. The user is root, and I'm going to set the password. Okay, so with this, I don't need to write on this script that is running on the IoT device any password or user. All I have to do is make sure that this user here, which is the one that is running on the MySQL database node, is configured via the MySQL config editor. This avoids having to send passwords to the other end. All I have to do is run the MySQL command, piping the SQL file into the database. So that's pretty much it in terms of setting up the IoT device. You only need to set this up once, and you have to make sure that the IoT devices both can connect to the database. Now I'm going to log into the other IoT device and make sure that the script is right. It also has a typo. Let me fix the typo. The typo is the IP address of the MySQL database machine. And that's it. This should work. Okay then, so on to the next topic, which is setting up the MySQL databases. Okay, so enough of setting up things on the terminal. Now let's start using the real power of Portainer. We are on item number 5, where I'm going to install the Ubuntu MySQL database on both clusters using Portainer. And on item number 6, I'm going to set up the replication between these MySQL machines or databases, also via Portainer. Same thing with the Grafana, steps 7 and 8. Right, so I'm here. I'm already logged into my Portainer machine, my Portainer instance, and I'm going to start by creating a resource pool or a namespace. I'm going to call it MySQL because I want to separate this from the default namespace. I'm not going to set anything here in terms of resource assignment because this cluster is going to be dedicated to the MySQL database anyway. And I'm also not going to worry about storage quotas for this node. Because I'm actually not going to use storage, it's going to be deployed as a stateless deployment. It's just for the sake of the demo anyway. Okay, so I'm going to create this resource pool, and in applications, I'm going to add MySQL. I'm going to use the Ubuntu curated image. As you know now, Ubuntu has a set of images that they support on an LTS mode, MySQL being one of them. I'm not going to use a stack. I'm going to have to add, because the MySQL database requires this, the MySQL root password. And here I set db1234, which is the same one I used when we configured just previously the IoT devices on the MySQL client on this node. And no persistent folders. I don't need this for this demonstration. And from a cluster perspective, yes, I will publish port 3306, sorry, 6 to 3036. Right. This is all I need for this MySQL database deployment. And you saw how easy that was. I mean, this is extremely easy and fast. It shouldn't take long until this is up and running and deployed. Let's see. Meantime, I can check events. It's pulling the image. Well, in the meantime, I'm going to the Charmed Kubernetes cluster and do the same thing. I'm going to create a resource pool or a namespace. Call it MySQL. Again, I'm not going to play around with resource assignments, not for this demonstration for now. I'm also not going to set an ingress here for now. I'm just going to create a resource pool, and I'm going to add the MySQL database to this Kubernetes cluster. Ubuntu MySQL environment variable, same thing. MySQL root password db1234. No, I'm not persisting data here. I'm going to publish this cluster with port mapping 3036 to 3306, which is default. This is the default MySQL database port. Deploy this application. So while it's deploying, I can go back to the MicroK8's cluster, see how my MySQL database, there it is, it's already running. So there you go. I have MySQL up and running on my MicroK8's environment. And let's see if on my Charmed endpoint, it's also up and running. Doesn't take long to deploy. And yep, there it is. Okay, so it's that simple. On the next video, we're going to see how to configure the replication between these two MySQL databases. Okay, so now we're going to set up the replication between the MySQL databases. Right, and for that, I'm going to move over to the left because there are some little things I want to show you that I would be on the way here on the screen. And I'm going to log in. admin user. And to make things easier, I'm going to log in on a second window here too. You will see why soon. So I have one connection here on this window to the micro K8's environment. And here I'm going to connect to the Charmed Kubernetes environment. So I can run both at the same time without having to go back and forth. Right, so here on the micro K8, as we can see here, we have MySQL running, and on the Charmed Kubernetes cluster, the same thing, MySQL running right here. Okay, we're up and running, everything's nice and healthy. Right, so I'm going to start with the micro K8's database. And the reason I moved here to the left is because I would be on over these two functions that are very interesting. One is logs, where you can see everything that's running on the MySQL or any application running in this pod. You can see the logs here. And the console. The console is a very powerful tool through which you can access the pod running applications in Kubernetes here with Portainer. So I don't need to use a terminal application anymore for anything within the Kubernetes environment. So here I'm going to access the MySQL database. Okay, I'm going to do the same on the Charmed Kubernetes environment. MySQL U -p. Oops. Sorry. MySQL -u root -p db 1 2 3 4. This is the database password. Okay, so now I'm connected to both databases, one on the Charmed Kubernetes cluster and one on the micro K8's Kubernetes cluster. Right, now I'm going to set up a user for both and grant them replication rights back and forth. And I have this written down on a notepad. I'm just going to paste the commands here. I created a user called Edge, identified by the password db1234, and I'm going to grant replication rights to this user. Same thing on the Charmed Kubernetes database. Okay, now next thing I want to check is show master status. And I'm going to write down two things. This bin log 002, and for this I'm going to write this on a text pad here. Oops, sorry, this is not what I want to. I'm going to copy this. And copy the position. Right. So you want to make note of this. This is the micro K8's cluster, which is running on 10.1.7, 2014. Right, now let's go to the Charmed Kubernetes cluster and do the same thing. Show master status. Right, it's similar, but they're never identical. It can happen even if they're not. It's very hard that it's the same. And you'll see why we're making note of this. This is required to set up the replication between the two MySQL databases. This is the Charmed environment, Charmed Kubernetes cluster. And all is running on IP 10.147, 2013. Another important thing that you have to do is make sure that the server ID is not identical on both MySQL databases. Otherwise, you're going to have a problem with the replication. So on the Charmed Kubernetes MySQL database, I'm going to set global server underscore ID equal to, could be 3, 4, whatever it is. Oh, sorry. You have to make sure it's different from the other MySQL database you're replicating with. Right. So Charmed Kubernetes MySQL database is running on with the server ID 2, and this one should be server ID 1, which is the default setting when you set up a MySQL database. Okay. Right. Now this is the command that we're gonna use to set up replication between these two clusters. So what I'm going to change here is the IP number. Right. So I'm on the micro K8's machine that I know is running on IP that ends with 14. And I want to make sure it replicates to the Charmed Kubernetes cluster MySQL database that is running on IP ending 13. Okay, I put in the host IP address, the port, the user, the password, and I'm going to put these variables that I wrote down. This is for the Charmed Kubernetes cluster, which is a bin log that ends with 2, but the position is 690. You have to make sure it has this variable also source SSL equal 1, otherwise it's not going to work. And do the same, but using the variables that we saw for the macro K8 machine just now. Okay. And here, we're just going to do it the other way around. It's going to be IP14. The bin log is the same, incidentally, but the log position is different. It's 689. I have to change this here. Copy, paste. Okay, now I can start the replica on both machines. Start replica, show replica status. I should see waiting for just for master some event on 13, and the same. Show replica status here. Okay, so it's working. Now they're replicating back and forth, which is good. It worked. Now we're going to create databases, one called Edge 1 and the other one called Edge 2. So the first thing I'm going to do is I'm going to create the Edge 1 database on the micro K8s. And this is just for the purpose of seeing the replication working back and forth. I'm going to create one database on one machine, which is the one running on the micro K8s, and the other one running on the Charmed Kubernetes cluster, and you're going to see that these databases are going to be replicated back and forth. So if I do create database, use database, create the table, yada yada, okay, you show databases. There it is, Edge 1. Now if I do show databases here, Edge 1 is there too. So I created on one MySQL engine, and it got replicated to the other. Now I'm going to do the same, but the other way around. I'm going to create a database called Edge 2 on the Charmed Kubernetes cluster. Let's see. Database Edge 2 is here. I'm going now on the macro K8 machine. Do the same. And Edge is here. Okay, so this shows and proves that the replication is working. Now we're going to start the script on the Edge devices to start populating the database on the micro K8's MySQL engine. Okay, so let's open our terminal here. I'm already logged into the IoT devices. I'm going to open a tmux session. Start the script. If everything goes right, and if everything works accordingly, we should just see the script sending the data to the micro K8's MySQL database. No errors. Oh, sorry, I'm on tmux also on Edge 2. And start the script. Yep. Seems to be working on Edge 1. Let's hope it's working on Edge 2. Okay. So it's reading the sensor information, writing that onto a file, sending it to the micro K8's MySQL database, and uploading the new information on the database. And it seems to be working very nicely. Let's make sure it is. Leave the session, leave that running on the background. Go back to Portainer, and let's say select. We're just going to use Edge 1. Okay, select everything from main. There you go. Starting to read and write onto the database. I'm on the microK8's environment. Let's do the same here. Use edge 1. Select from main. Oh, sorry, main. Oh, I didn't select the database, did I? Select, sorry, typo, from main. There you go. Well, let's do the other way around. Let's use edge 2. See if it's working. Yep, it's working. Same thing here. Use edge 2. There you go. So now the databases are replicating. Basically, from the topology view, we see that the IoT sensors are sending information to the microK8's, or better said, to the Ubuntu MySQL database running on the microK8's cluster, and this is being replicated via the VPN Mesh to the Charmed Kubernetes cluster that is also hosting a MySQL database. The final step is to install Grafana and set up the Grafana console. So, okay, we will see this right away. Right, so now we're going to step 7 and 8. 7, install Ubuntu Grafana, and 8, set up Grafana. I'm actually going to do everything here on one single step because it's quite easy to do both. And I'm only going to install Grafana on the Charmed Kubernetes cluster. And for that, I'm going to do the following. I'm going to set up a resource pool called Grafana. An ingress for this console. For that, I'm going to check the IP address of the node, the public IP address of the node that will be hosting Grafana. Well, it's easy in this case because there's only one machine, right? But if I had more than one machine, there's two ways to do this. You could, well, deploy Grafana, check in which machine it would be running, and then pick the proper public IP address of that machine in order to set up the ingress controller. The other option would be to use a load balancer, but in this case, I'm just going to use this IP address because I know I only have one host, so I know this is the public IP address of this host. I'm using Grafana.the IP address.nip.io. Right, so I'm creating this resource pool. Now I'm going to add the application, and that would be Grafana. I'm going to use the Grafana resource. Now, first, before doing this, let me show you something quite interesting. Down here on the publishing the application, I only have two options, internal and cluster. The minute I select Grafana, Portainer realizes that this resource pool has also an ingress controller attached and configured into the resource pool. And I also have the option of using the ingress publishing option. And I'll have the ability to use the ingress publishing option. Right, no stack, no environment variable, configuration, none of this. I'm just gonna go ahead and deploy it right away. Again, this is a demonstration. If you want persistence, you have to configure these. If you have specific environment variables, configurations, this is just for the demonstration, so I didn't need to set any of this. So with the stateless deployment, I have all I need to have Grafana up and running and finish the demonstration. Okay, I'm going to deploy the application. It shouldn't take long. Grafana is quite fast to deploy. Let's see. Okay, and there you go. Right, so now let's go to item 8. That is configuring Grafana. I'm not going to install Grafana on the microK8's cluster. in the demonstration I did, but the steps I'm going to show you here on the Charmed Kubernetes cluster are the same for the MicroK8's cluster. So it doesn't make any sense to repeat that. Right, I'm going to click here on this HTTP route, and it should take me to the Grafana application. And as you can see, there we go. So the first to log in is admin. Grafana asks you to change password. Let's start by adding 2 data sources. Those are the MySQL databases we have here. I'm going to call the first one Edge1. I know the host IP for this machine is 13. The port is 3036. The database is Edge1. User root. Password is DB1234. Now let's cross our fingers and hope this works. And yes, it did. Now let's go and add the second source. That's the second database. I'm going to call it Edge2. Same thing. IP address. And this is the IP address I'm using with the VPN Mesh. Name of the database is Edge2. User root DB1234. Save and test. Okay, good. So now we have the 2 data sources configured. The 2 MySQL databases. They're being replicated from the MicroK8's environment that is collecting data from the 2 IoT devices. All right, now let's add a dashboard here. Add a new panel. It's not time series. Okay, let me get out of the way here. Let me go all the way to here. I should be fine. Okay, good. Right. So it's not time series. It's actually table. And the SQL. It's a simple table. I'm gonna paste here a simple SQL statement for Grafana, where I pick humidity and the temperature. That's what's running our database. As you can see, this is the same as the database that we were using in MySQL. Let's try this visualization here. Let's see. Right, there you go. It's up and running. Lovely. Let's call it indoors. Apply. Let's go for the second one. That's Edge2. Same thing. Table. SQL. Paste. But now I have to use Edge2. Spirit outdoors. There you go. Look at this. This is nice and lovely. Right then. So I have the outdoors and the indoors readings from my IoT devices that are writing data to the MySQL database running on a MicroK8's cluster that is replicating the data via a VPN mesh to my other MySQL database that is running on a Canonical Charmed Kubernetes cluster. This MicroK8's cluster is running on a local network. It's a virtual machine. It's a tiny virtual machine. It's got 2 gigabytes, 1 CPU, I think. It's really small. And this as well, Charmed Kubernetes cluster as well. It's got a lot more resources. Usually when you deploy a full Charmed Kubernetes cluster, you have 8 machines running on your cluster. So this is like for when you have an environment that demands a lot of resources. So this is a demonstration. Okay then, so this was the behind the scenes of the Kubecon demo we did with Canonical during Kubecon Europe last week on May 7th. I hope you enjoyed this video, this tutorial, as much as I enjoyed making it. So thank you very, very much for your attention.